Okay, really quick video by request for you guys in 9G2. I'm going to talk a little bit about adding mixed numbers, show you how to do it. I will show you why adding the whole number parts and then working out the fraction parts is the way to go when adding, and I'll also show you some of the pitfalls with subtracting as well, and then we'll do some questions. Okay, so I've got an example question here, 4 2/3 plus 2 1/5, and this is how I'm going to go about doing it. First, I'm going to add the whole number parts. Okay, so 4 plus 2 is 6. So effectively this question is the same as doing 4 plus 2, which is 6, plus the 2/3 plus the 1/5. Okay, so straight away we've sorted out this mixed number part, or the whole number part of the mixed numbers, and we're just into an adding fractions question now. And we're going to use the same technique we used previously, list out the multiples until we find a number common to both lists. I'll do that over here because I've got a bit of space. So multiples of 3, 3, 6, 9, 12, 15. I know 15 is in the 5 times table. Okay, 15 appears in both lists, so 15 is going to be our common denominator. So 2/3 equals how many 15ths? We have to multiply 3 by 5 to make 15, so we're going to multiply the top by 5 as well. That gives us 10 15ths. 1/5 can also be converted into 15ths. How many 15ths? Well, we have to multiply 5 by 3 to make 15. So we're going to do the same to the top as well. So we've got 3 15ths there. Okay, so now our question, put an equal sign down there. We have got 6 plus 10 15ths plus 3 15ths. Okay, which gives us altogether 6 and 13 15ths. Okay, I'm just going to neaten that up there just because that looks a little bit messy. Okay, there is our answer, 6 and 13 15ths. And that's pretty straightforward. Here is an example. What have I done with it? Oh, there it is. Okay, that's what it would look like if we were to do the same question by converting everything to improper fractions and then adding. The difficulty comes when we end up at this stage. We've converted into improper fractions. We've got 14/3 and 11/5, but then when we convert them to a common denominator, we end up with 70 over 15 and 33 over 15, and we just end up having to work with larger numbers than we really have to. So if it can, I would avoid doing this. You don't need to be doing this. Okay, now we've looked at adding mixed numbers. I'm just going to talk to you about some of the pitfalls of subtracting mixed numbers. Okay, so we've got 3 and 5/9 take away 11/4. Adding questions could be phrased with a mixed number and an improper fraction, or you could even have subtracting questions where you've got a mixed number and an improper fraction. Could do a couple of things here really. What we could do is we could convert our mixed number into an improper fraction, then work on that. Or we can convert our improper fraction to a mixed number and work with that. What I'd like to do, I think, is work with mixed numbers. Okay, so 11 over 4. How many 4s in 11? We've got 2, which is 8, and then 3 remainder, so that's 2 and 3/4. Okay, so now our question is 3 and 5/9 take away 2 and 3/4. If we have a look at our fractions, we could have a little bit of difficulty coming up because 3/4 looks like it's going to be larger than 5/9. Okay, but we'll persevere with it. So 3 take away 2 is 1. So we've got 1 and 5/9. Take away 3/4. Okay, let's see what we can do with this. So, going to find a common denominator, and our common denominator is going to have to be 36. Just list out our multiples of 4. First one that's in the 9 times table, I'm not going to list out a load of 9s as well, but the first one that's in the 9 times table is 36. So we're going to have to convert both of these to 36ths. And for the sake of not taking ages with it, I'm going to do it without showing you the working. So 1 and 5/9 is going to be 1 and 20 36ths. Take away 3/4 is going to be 27 36ths. Right, and our difficulty with this fraction being larger than that fraction has appeared. So we're doing 1 and 20 27ths, take away 27. No, hang on, sorry. 1 and 20 36ths, take away 27 36ths. Okay, so we're taking away more 36 than we started with. Doesn't actually represent that much of a problem. If we remember that in a whole one, in this whole one, there are 36 36ths. Once we've taken away once we've taken 20 36 away, there's still going to be 7 36 left. Okay, so we're going to have 1 minus 7 36. 36 36 altogether. That leaves 29 36. Okay, just to reinforce that, I'll just convert this into a mixed number. 1 and 20 36 equals 56 over 36. 56 over 36, take away 26. 56 over 36, take away 27 over 36, leaves us with this 29 over 36. If you convert them into improper fractions and work that way, that's fine. Just persevere with it and you'll get there. Job done.